Dmitry Ivanovich Mendeleev, a true genius, and the world remembers him for his immense contribution in the field of chemistry. His incredible contribution is his Mendeleev periodic table to chemistry. Seriously, what an effort by him in classifying all the then available 63 elements. Yes, he could arrange all the available 63 elements which none other scientist or chemist were able to achieve or do before him. He was a true pioneer. He arranged all the available 63 elements in a chart called as Mendeleev periodic table, where the elements are arranged in horizontal rows called as periods, and the similar chemical properties of those elements repeats in a group. Let me simplify. The elements which fall in the same group, same vertical columns, possess similar chemical properties. Hello and welcome to our new session. In this session, we'll be highlighting all the merits of Mendeleev periodic table. Along with that, we'll discuss in detail some of the anomalies, significant anomalies, the defects of his Mendeleev periodic table, and the kind of questions that appears in boards, that comes in boards over the year from this topic. First thing, Mendeleev's periodic table, as I said, I will repeat once again, 63, all the available 63 elements were successfully arranged by him in his periodic table. Atomic mass was the base upon which the elements were arranged. So, Mendeleev periodic law states that the properties of elements are a periodic function of their atomic mass. The atomic masses of those elements which were lighter were placed earlier, were placed before, and gradually with increasing atomic masses the elements were arranged. Another important highlighted feature of his table was that he left gaps. He left gaps for yet to be discovered element. Those elements which were not discovered at his time even, he has idea that in the near future those elements are going to be discovered. He left proper gaps for them. He described their properties already beforehand and he even named them. For example, Eka-boron was not discovered at his time, so he left that gap after boron as Eka-boron, Eka-silicon and Eka-aluminium. Let me explain what is the meaning of Eka here. Eka means the position, the first position after boron. The first position immediately after boron in the same group was left blank, and later on it was found to be nothing but scandium. Scandium. When it was discovered, it was found to be scandium. Eka-silicon, he left the gap immediately after silicon, and that gap was named as Eka-silicon, which was occupied exactly by your germanium. The element germanium occupied this space, and Eka-aluminium space was occupied by gallium. Gallium, scandium, or even germanium were not discovered at his time, but he left the gaps for them immediately after boron was called as Eka-boron. After silicon, it was Eka-silicon. Later on, it was occupied by germanium and Eka-aluminium. The space immediately after aluminium was called as Eka-aluminium. The element he named as Eka-aluminium, and later on it was found to be gallium. So he successfully predicted the properties of not yet discovered at his time. Some of the highlighted features of this, that particular Mendeleev's periodic table consists of 7 periods, the horizontal rows in which the elements were arranged in terms of increasing atomic masses, and 8 groups. Yes, 8 groups. The elements which were present in the same group were having the same number of valence electrons. For example, lithium, sodium, potassium which were the members of group 1. In group 1, lithium was there, sodium and potassium along with other, and each of them has a valency of 1, and which represent their group number, and he found out that the properties of those elements which were in the same group were similar in chemical properties. But now we are reaching a critical moment here where we'll be discussing the drawbacks of his. Now in the board, this is a favorite topic for the examiners to set questions on the drawback of Mendeleev. This is frequently asked, the drawbacks. The drawbacks are very important here. First drawback, position of hydrogen. Although he successfully arranged all the 63 elements, but hydrogen was the unlucky one not to find any proper place in his table. Jokes apart, hydrogen could not be assigned any proper place, any fixed place in Mendeleev periodic table. Why? Let's get into a bit deeper reason. Hydrogen possesses similar properties with alkali metal because hydrogen has one electron in its valence shell. It can lose one electron very much like the alkali metals, lithium, sodium, potassium, to form electropositive ions. And at the same time, hydrogen has the ability to gain electron. It shows electronegative character, very much like the fluorines, chlorines and bromine, the halogen elements. So hydrogen could not be assigned a proper place in his table. Second major drawback was similarly position of isotopes. Isotopes were having same atomic number but different atomic masses. So isotopes were not discovered at his time even, and he could not have any idea, any clue about the properties of those, and he didn't left any gaps in his table. So isotopes were not having any space, any place in his periodic table. That's one of the biggest drawback of his periodic table. Third, only some. Remember, choice of words is very important in board. Many students write that the elements were arranged in wrong order of atomic masses. Wrong. This answer itself is wrong. Only some of the elements with heavy atomic masses were placed earlier. Some heavier elements were placed before lighter elements. Before lighter elements. For example, cobalt was placed before cobalt with atomic mass of 58.9, though heavier than nickel was placed earlier than nickel. Nickel with atomic mass of 58.7. What Mendeleev tried to justify this point of arranging cobalt, although heavier, before nickel, that cobalt was having similar properties with other elements. That's the reason why cobalt is found before or placed before nickel. He could not justify properly, in fact, he could not satisfy. So that's another drawback. And one more element, argon with atomic number 40 was even placed before potassium with atomic number 39. Now another drawback of is some of the dissimilar elements, some of the different elements in terms of substantial difference in terms of properties were placed in the same group. We know in a group the similar elements are placed, but some of the, for example, in lithium, along with lithium, sodium and potassium, copper and even gold, copper, silver, they found a place here. Although copper, silver are very less reactive. These are very less reactive. whereas these are highly reactive metals, alkali metals. So there were total mismatch in terms of property, but still he arranged copper and silver along with group 1 elements lithium, sodium and potassium. That's one of the major drawbacks. Even some similar properties were placed in different groups. That was another drawback. So these were the 5 significant drawbacks. Drawbacks means anomalies, defect, shortcomings, all the words means the same thing. In the board, generally the drawbacks are a favorite topic for picking up by the examiner. So prepare well from the drawbacks. Along with that, the gaps, why certain gaps were there, how those gaps were managed meticulously by him is again very important conceptual wise. So till then, we'll meet in a new session. We'll discuss the modern periodic table and the highlighted features of that table also in great detail in the next session. Till then, bye bye, take care and take extreme good care of your health. Bye bye and take care.